Hey there. Hello, Gophers. I miss the intro. I'm Dominic St-Pierre.
And I'm Morten.
And we have Pasha Zviderski today. So, hello. Hello there from Australia.
Hey guys.
So, you are the creator of Uncloud. I came across the project, I think it was on Blue Sky a couple of weeks ago or something like that. I was not aware of it. So very nice, and we will dive deep into this. But first of all, can you go ahead and talk about you a little bit, where you're coming from in terms of where have you discovered Go? What is a little bit of your background? Anything that you want to share, regarding your path so far in programming?
Yeah, good. I'm a software developer from Belarus, currently living in Gold Coast, Australia. So my background is mainly infra and backend development. Some recent jobs I worked at were Canva and JetBrains. So at Canva, I mainly maintain the compute infrastructure of clusters, first on AWS ECS, then led the adoption of Kubernetes. And then probably over the last year of my work there, I helped develop the internal platform, the PaaS or internal development platform, like different names of this stuff at companies. And we developed this on top of Kubernetes with a mix of Crossplay and Terraform and all other stuff. And this is probably the time when writing Go became my day job. Before that was mainly Python, some scripting, and just operations in infra space. So yeah, haven't been using Go for a long time, maybe just a couple, 3 years or something, but have strong background in just software engineering.
Very cool.
Yeah.
JetBrains. Oh, yeah. So I'm curious a little bit about that. So I guess that was the Python part?
Yeah, that was the Python part. So I worked at a sort of small startup within JetBrains. So the JetBrains is famous for its IDEs and all other dev tools. But this was something similar to Coursera, Udemy, like a marketplace for online courses. So it's just a backend developer and part like 50-50 backend developer in Python and infra guy.
Nice, interesting. Okay, and I've heard a lot of Kubernetes and configuration and things like that. So would you say that this kind of sparked the idea around Uncloud at some point? So what happened there? When have you gone from, it's nice that we have all this on, either a platform as a service on a cloud provider, and the idea of, maybe it's time to build something for self-hosting and having a PaaS, more separate from the cloud.
Yeah, so probably the last job of building a PaaS on top of Kubernetes sort of led me to think in my life decisions. And the real reason is probably that I'm intolerant to unnecessary complexity and over-engineering. And the Kubernetes ecosystem and cloud-native landscape is the great example of this. I've built info for many projects, product of different scale, and for most of the cases, Kubernetes adds more problems than it solves. And many people agree to this statement, but then ask a fair question. So what instead? Like what's the alternative? And that is the actual problem. There are no decent alternatives, unfortunately. So I'm not talking about cloud vendor solutions. There are plenty, right? And Kubernetes undoubtedly won the space, and everyone is building just on top of it, adding more and more abstractions and indirection layers, and again, increasing the complexity. And perhaps I just wanted to scratch my own itch, as it usually happens, and have a simpler tool that basically connects a handful of Docker hosts and deploys my containerized apps to them without going the full Kubernetes path. But regarding alternatives like Cloud Foundry is dead, Mesos dead, HashiCorp has been sold to IBM, and the future of Nomad is not bright. Docker Swarm has been sold to Mirantis many years ago, and it's in a weird limbo state at the moment. I haven't seen much development and inventions on the Swarm side for years, even though it sort of still works, but there is a ton of open issues. So yeah, let's just bring us to like, let's try to do something about it. And so yeah, I just started experimenting, and Uncloud is at some stage of this experiment, which is going pretty well.
Very cool. Are you saying that IBM is not a good? I won't go there. That's what I tried to do a joke, but I won't go there. It's refreshing to hear. I will be frank. So myself, I've been going away from cloud infrastructure for a long time now. But at first I was all in there. I started. Interestingly, I was a .NET developer in another life, and there was this pass at first, which was called App Harbor, and their H1 was Azure's done right. So it was when Azure was starting. So they they were the Heroku of for .NET developer, if you will. But that's interesting to hear. So would you say that the weight of configuring everything, and can you pinpoint a couple of problems that you can remember maybe vividly that you faced that just did not really make sense at some point, and what caused this way of thinking, anything that you can pinpoint?
Well, you mean pinpoint the problems with Kubernetes specifically? That was
maybe, or just in general, what kind of the solution was looking like, because you were saying that you were kind of developing a in-house, if you will, platform as a service, which from what I can understand is kind of a huge deal. So I can understand that there has to be some things that happen that I don't know that you said if I were to restart, I would not do that this way.
Yeah, so I guess we can maybe talk a bit more about push and pull deployment model. That's maybe where the distinction or pain comes from. So maybe, 10, 15 years ago, we were all deploying SSH into the server, uploading binaries. Many people still do that, and it's fine. Then we or maybe even earlier, it was just putting the PHP files on FTP, and that was the deployment process. And then at some point, we invented Ansible, and this allowed us to sort of automate or script these deployment processes to make them repeatable, reproducible. And the push deployment model works best for not so big scale, and it has very good visibility, and it allows to very well see when something fails, you can quickly see what went wrong, what stage or what step some command failed. And then with Kubernetes and other container orchestrators, we invented, I'm not sure if it's correct to say a pull model, or maybe a reconciliation loop model, these sort of things, when you define you declare your desired state, and then the system somehow makes it happen or reconciles it to to this state. And in this model, this model works very well for large scale. It's probably most of the times at large scale I'm considering like thousands of nodes, for example, like thousands, tens of thousands containers or applications. It's probably impractical to like orchestrate or to manage applications in a imperative way for such scale. So this like orchestration model like Kubernetes works pretty well here, but the downside is it's the visibility and possibility to troubleshoot such a system is really bad. So we have to invent all these like monitoring tools and some like events, login to just understand how this system works. And like when you just push your manifest with your application to the cluster, then something happened, something failed, and you have no idea like where to even start to dig into that. Yeah. And probably this is what just I became sick of. And when we built this platform on top of Kubernetes, we added even more abstraction layers on top. So we used this reconciliation loop to provision not only Kubernetes applications, but also to manage all sorts of infrastructure resources, like provision, like a virtual machine, provision S3 bucket, provision IAM policy in AWS, and then like work out dependencies between these resources, and finally, sort of the user interface is sort of like they put short YAML file with the application and everything just happened. And this worked brilliantly when it works. Yeah. But then when it doesn't work, it's just a nightmare to troubleshoot. There are so many indirection layers and so many like GitOps and stuff involved so that just a nightmare for users, for operators, for other teams who build this thing. So that's where I'm sort of coming from to like, okay, probably enough of it, and I want something simpler. And I also have some Kubernetes, or had some Kubernetes cluster for my just home network, home infrastructure, and every time I had to do something with it, I was like I usually started with a big sigh and like, oh, how to do this again. It's like you open the manifest and it's like, oh, I already forgot what I put here, and like I need to figure out where to start. And probably LLMs help now. So I started it like just at the probably beginning of when AI and LLMs start to become popular. But it's still like complexity doesn't go away. It just makes it easier for you to configure to understand this YAML files, but all the other stuff is still there.
Totally.
Yeah. Press the magic button and hope it outputs something that works in a big system. It's not always fun.
Yeah, exactly.
Okay, and let's start to dive a little bit on Uncloud. I really like the name, by the way. But why Go? So have you had to take a decision at some point? Maybe have you considered anything? Maybe Rust or anything like that? Why Go?
For me, it was obvious decision. It's just like standard de facto language for infrastructure tools. So most of the tools that I worked with were written in Go, and I used Go in the last couple of years at my previous job. So it was just obvious decision for me, and I just like the static binary, the way to just build one binary and upload and run it. Yeah. And then probably the concurrency part of the language also helps a lot with building what I'm building. as we're running an agent or a daemon on each machine. It runs several controllers or control loops, and this concurrent model with coroutines helps a lot.
Yeah, that sounds good. So I was going to ask about the agent. So let's start with the beginning. So how would you describe Uncloud, and for someone that never heard of it?
So in a nutshell, Uncloud is Docker Compose for production. Let's put it that way. That's the shortest description I came up with recently. Not sure if it's well described, but if you're familiar with Docker Compose that runs on one machine, or you can use it locally for local development, for running a bunch of containers together. It's an open source tool that gives you multi-machine deployments, rolling updates, overlay network, service discovery, and load balancing without the complexity of the traditional container orchestrators such as Kubernetes. So you put your service definition, configuration in a familiar Docker Compose format. If you're familiar with it, but it's much simpler than Kubernetes manifests if we want to compare it to Kubernetes. Basically write a compose.yaml file, then run one deploy command locally, and it builds and rolls out your application to your servers. So it's your servers, basically self-host your application. So you set up your own machines. It could be cloud instances, could be on-premise, and you can mix and match them.
So what about the machine itself? So let's say I install the tool on my development machine, and now I have 3 servers. You seems to be using the 3 servers example a lot. Mm-hmm. What happened when I add a machine? My main question is regarding load balancing. I'm very, very curious about load balancing. Who's deciding which of the machine is going to have the HTTPS termination or the entry point to my service, for example?
So so let's try to sort of go through the setups steps. So you run the machine init command or machinenet command to initialize the machine, or initialize the first machine, or add another machine to the cluster. And this command installs a daemon on the machine and connects to establish WireGuard tunnels and connections to other machines. So every new machine that is added to the cluster is added to the overlay WireGuard mesh between these machines. And we also install Caddy as a reverse proxy. This is for now just opinionated decision. So Caddy is used as the only option. Probably some other reverse proxy could be supported in the future, but now just for simplicity, it's only Caddy. And Caddy is installed on every machine, or not installed, Caddy container just runs on every machine. But you can also configure which specific machines you want to run. But by default, just runs on every machine could be an entry point to the cluster or to services. So you can create a DNS record for your public domain, point it to one of the machines with a public IP, and it will. So Caddy will issue a certificate automatically and will reverse proxy the request to services.
Okay, so basically it's the it's the public DNS that kind of decide which is the elected machine that will receive the first request, and from there the load balancing is done with Caddy.
Yeah, so the Caddy is ingress, right? The or reverse proxy part. So you can front it with a load balancer, like a cloud load balancer, for example, and then this is independently configured of the Uncloud setup. So you can create a load balancer, create 2 targets, 3 targets if you have like 3 machines, and then you will be the traffic will be load balanced by this load balancer to multiple Caddy instances. And then each Caddy instance will reverse proxy to a specific service container. So you can point DNS or you can point load balancer. So it's up to you. So there's no sort of requirement or like that. It's not opinionated at this part.
So you would have something like, I don't know, Cloudflare's or Hetzner's load balancer in front if you want to load balance between each target. Is that correctly understood?
Yeah. Yep.
Yeah. Cool. I really like your design, by the way, with the Uncloud daemon. That's I'm doing a little bit of a similar project, and I chose a similar path. It really is cool to see that you also went with the Uncloud daemon. I was very curious if you was actually load balancing on a per daemon basis since you had the private network, but cool. That sounds really cool.
Yeah, the daemon is mainly needed for, we can probably dig deeper into this, but it's needed for like coordinating this networking stuff, sharing information about running containers for service discovery and things like that. And also for connecting connecting your client, like your CLI commands to the cluster. So this is the main purpose of the daemon. But then when like for user traffic, it doesn't take part in any request serving. So the request served by like Caddy and the application containers.
That's cool. And do you do any do you do any different kind of like deployment methods, or it's mainly rolling updates and then you handle that through the Caddy API or admin API, or how do you tackle that?
So the moment we implemented rolling update, so it's basically just rolling one container at a time, waiting for like a new container to start, pass the health checks, register in Caddy, and then when it's healthy, we can remove the old container and then repeat this process with the next container and until all containers are rolled out. So yeah, this basic rolling deployment, similar to deployments in Kubernetes, I guess. I thought about like blue-green, immediate deployments, things like that. But yeah, for now it's just one strategy for simplicity. We'll see what's needed in the future.
That's nice. Yeah, I have immediate and blue-green in my product, and I don't have rolling, but I had a plan. So it's funny that you mentioned it. I basically did it with the admin API for Caddy, which is very cool, and I just used the load balancing feature. So it's actually fairly simple to implement. Caddy is a really cool project.
Yeah, what load balancer feature do you use? I'm not sure.
They expose like an admin API, so you can actually load balance inside of Caddy to different targets. So you can just manage that through the admin API, and then you can change the weight on each target that you want Caddy to load balance to. Is not really the right word, right? But it can distribute incoming traffic to different targets on the server, and then you can manage those weights with the admin API, and then you don't need to do a Caddy reload or anything to have those be applied.
Yeah, right. So the load balancer you're talking about is part of the reverse proxy stanza, or this is not the reverse proxy? So remember there was we use like load balancer passive health checks, if I recall correctly, under the reverse proxy. But you're talking about probably something different, or not?
Maybe I'm explaining it badly. Are you familiar with the admin API that Caddy exposes?
Yes, of course, yeah.
And they have
use it to reload config.
Yeah, of course. Okay, so like they just have a what is it called, LB weighted policy underneath, so you can set weights on each target that you want after the reverse proxy happens, like how the container, how Caddy then sends out traffic to each target on the server.
Yeah, it's similar to Nginx. Nginx also does that. It's like local balancing. That's why I was asking that question at first. I was curious to see if one of the nodes was the primary node or something like that were using the reverse proxy to do the load balancing.
Yeah, just check I know what you're talking about. Yeah, just to just answer the question if there is some primary node or not, it doesn't matter. So every node with a running Caddy can work as an ingress. So it's up to you to decide like which nodes you want to use for like receiving traffic from the internet or from your private network, and all Caddies are just configured equally. Yeah,
but you still need an external load balancer to spread out your requests to
of course. You have to front this with either probably the DNS. We mentioned DNS, but DNS with for example, Cloudflare DNS has a proxy feature. You can like enable just DNS or proxy, and the proxy feature is what I call it like a poor man's load balancer. So if you create multiple A records for your domain and enable proxy for each of them, it will do automatic. It will run. Actually, it won't run robin. It will connect to the closest one, depending on the user. So which edge node the user connects to, and it will route to the closest one from the like Cloudflare edge server. But then, if that server is down, it will automatically fall back to the other one. So it will retry on the Cloudflare side. So the user won't even get like 500 or anything. It will automatically retry, and if it's successful, then a user will receive a response from another server.
Are they marking the server as not clear for a couple of minutes, or the next request it will still try it again and fail and now fall back?
And to be honest, I'm not sure. This isn't clearly described anywhere. Okay. So I just tested it. It works like I described, nice. and they have this in docs that it will fall back on 5xx errors. So yeah, this is pretty good, and it's free. Like I'm not sure like what amount of traffic it's free, but for all my stuff it just works well.
Yeah, based on what I heard of Cloudflare, it's free until it costs you $10,000. But still,
that's fair. That's fair.
Still very very generous feature. I'm just curious to return a little bit to the network part. I'm very interested in that. So let's say two of the three servers are not at all in the same region, and maybe even not. Maybe I have one server at my home, for example, one server at a cloud provider, whatever. So are they just communicating with them via SSH? Is that what I'm not sure about the WireGuard mesh. So is it like a VPN similar to Tailscale or something like that? It's just able to communicate with other servers via SSH?
It's not SSH. It's just WireGuard is UDP. So it's just basic UDP traffic. So Tailscale uses WireGuard under the hood. So in Uncloud, we use just vanilla WireGuard. So how servers connect? So yeah, it's basically like a VPN. So we create a virtual private network between these machines that are located in different networks, probably in different regions behind net. So the current requirement so that all machines communicate successfully is that for each pair of machines, any of the machines in the pair have to be able to reach the other machine. So maybe it's a bit hard to comprehend, but basically you can have like one public machine in the cloud and several machines in your private home network behind net. This setup will work perfectly. So each pair of machine within your private network can directly communicate to each other. And when we take one cloud machine and any other machine in your private network, then they also can communicate, because any your home machine can reach the public machine by its IP. So basically, we just establish like a full mesh. So each machine establish a WireGuard tunnel to every other machine. And so this is like a full mesh topology, and this forms like an overlay network. So then machines and containers can talk over this network to each other.
Very nice. So what? UDP is always open. It's never a closed socket in any firewall and whatnot. So do I need to open that?
Yeah, you need to open like 5051 820 UDP port. So yeah, this is WireGuard. Yeah.
Oh, nice. Oh, very interesting. Okay. So it starts to make sense. So when I issue a I think it's the run command to deploy, right? You see run is doing what exactly? Is it creating a Docker container on my machine and sending that to the agent, or it's sending a command to, I don't know, how does it transfer my service to all my servers?
Yeah, okay. So deploy commands can build container images. So compose specification. So just maybe to add a bit more context about compose and why compose. So Docker Compose is just an implementation or reference implementation of Compose spec. But there is also Compose spec website where it just basically defines all the parameters, attributes for Compose file, and you can essentially implement your own implementation of this specification. So there is like customize, for example, or not customize, compose with K for Kubernetes. So basically to support compose format to deploy to Kubernetes. So basically Uncloud doesn't use Docker Compose directly, but just uses its Compose spec. And at the moment, it implements only a subset of features or attributes, not all of them. And like over time, it just add what makes sense. So Compose supports a build stanza, a build block in the definition, where you can define like use this Docker file, use this context, basically like configures Docker build process, like what platforms to build for. So if you want to build your application code, you can specify this build block, and then specify some like deployment configuration, what memory you want to use, what port to publish, and then the deploy command if it finds the build block, it builds a container image. Then it uploads this container image directly to your remote servers where you want to run the service. So this part, I think, is quite different to most of the deployment tools and orchestrators. Usually, the next step is to upload to container registry, but we intentionally eliminated this step to just reduce the friction, because to my experience, like, I'm not saying the registry is not needed. It has its place in many setups, but just for my personal like use and in many ways, it's gets in the way often. So we built another project called Unregistry. I'm not sure if you heard of it. So we can talk about this. But basically, what it allows you to do is to expose your Docker or containerd daemon as a registry API. So each machine, essentially each Uncloud machine, is essentially a container registry. So you can think of it like every Docker daemon has its own image storage. So it needs to pull images in order to run them, and it has internal cache, internal storage for these images. So why can't we just use this storage for, like, when we want to deploy, just directly push to this storage instead of pushing to third-party registry and then pulling from registry back to the server? So so we built this unregistry component to be able to push directly to service. We pushed the image to machines, and then the deploy command starts the rolling deployment process for each service according to dependencies, the order specified in the compose file. You get your service deployed. Probably maybe like a note about what it prints. So it also so I took some inspiration from Terraform tooling. When you want to make a change to infrastructure, the Terraform shows you a plan, so you can see what actually will happen, and you can review and approve it. So Uncloud Deploy also prints a deployment plan, and it prints it like in the exact order, what containers will be replaced, what new containers will be started, what will be removed, what volumes will be created, and so on. And you confirm it, and then the execution of this plan happens. And you can, of course, auto-approve it to run it on CI, for example.
Sounds very, very cool. I was not aware about the unregistry part. Does that mean that the artifact that we are sending is kind of big? So I guess if it's all built locally and sent, it's like 500 megabytes that we are sending each time we are deploying.
Yeah, that's correct. But that's actually why we built this layer, the unregistry part, to not send the full artifact every time. Similar to images, when you deploy for the first time, yes, you transfer in the whole image, or maybe except the base image. But then, if you're just rebuilding the last couple layers with just your application, it's usually not big, and this allows you to just upload the changed layers.
Wow, that is so interesting. So wow, okay. So without entering into too much detail, because I'm kind of very intrigued now. So if there is some parts that will exist, I guess, and you know that might show how little I know about this thing, because I'm not sure what exactly it means to build a Docker image in terms of the binary that you're receiving. But let's say you have the base system, so it means that on the Uncloud machines, I would have somehow the basis system built there, and now I'm only sending what changed from my service, and somehow it's able to merge that together. I'm not super clear about, because from my point of view, I thought when we do a Docker build, it just build everything from kind of scratch. I know there is some caching and whatnot. I'm just unclear about what gets cached actually. Do you know that?
Yeah, so it's probably a lot to unpack, but yeah, try to be concise. When you build images locally with just Docker build, it has a inbuilt sort of cache system. So it checks, like if you didn't change your Docker file and the files on the file system haven't been changed, then some of the run commands in the Docker file, they're just coming from cache. So basically each run command in the Docker files that like does some build, copies file or things like that. This is a separate layer in the resulting image, the resulting artifact. So the image consists of multiple layers, and each layer is usually created by one command in the Docker file. So like when you built in locally and you didn't change much, so maybe half of your Docker file is actually taken from your local build cache on your local machine. If you're building on CI, then again, you can use some cache on CI agents, or you can use like GitHub Actions cache or some other, there are other tools and even like cloud services for building images to utilize the cache heavily. So, and when you upload this image to machines, so like if you're just starting with empty machines, then there is no cache on these machines. So the first upload is probably takes the longest. But then if you're just changing a few last layers in your images, then you will just upload them when deploying with Uncloud. It's very similar to how would you push them to a container registry. So when you push into the registry, you also uploading only the missing layers, only the changed layers.
Yeah, I'm just unclear about, what kind of binary data we're talking about. Yeah, but yeah, maybe it's way too much detail at this moment. That sounds great. So any challenges that you faced so far with the development? Anything that that you thought might be easier and it got complicated and things like that? So where are you at the moment with all this?
So probably maybe not the technical challenge, but the main challenge is to keep things rolling. Working out a sustainable business model is the primary concern and the primary challenge. And yeah, this part is haven't worked out yet, and but there are already some users. There are some people who adopted Uncloud for their side projects or home labs, but I guess the goal is to make it more usable for serious businesses, for like solopreneurs, small teams, and I'm saying small teams first because it's not many capabilities are available for like multi-user support and things like that, and I don't want to over promise anything and oversell here, but like to make it possible so other businesses could depend on Uncloud and be confident and it will thrive and they'll get the support they needed is probably the biggest challenge now.
Yeah, totally. It's very hard to to do it. It's akin to marketing in software as a service. I can. It might be worse for open source project actually. Sometimes.
And especially in the we're covering the self-hosted space, so that the whole purpose is to run it on your own servers, on your own infra, right? So it's kind of. It's called Uncloud. So what will I propose? Like Uncloud cloud? It's silly.
What do you mean? So GCP is not going to found you? Is that what you're saying?
Yeah.
I mean, have you? Because I can see in your docs that you also mention Coolify and Dogploy. Have you played around with their pricing models, or at least their approach to make it to funding or to business side of things?
Yeah, of course. I keeping an eye on them, but not trying to pay too much attention to just not start copying their approaches, but try to be distant from their decisions. So my current plan or idea is to build sort of a control center or web UI, both self-hosted and managed, for managing clusters and applications, probably with some PaaS, platform as a service, features on top of the current Uncloud clusters. I guess this is similar to what they do, but I guess they're the whole sort of platform, or like their application is this thing. So it is what drives the deployments, what manages everything. I wanted to make a little bit more composable. So this control center, I'm considering it will be off the critical path. So the current clusters can still, or machines in the clusters can talk to each other, run application and stuff, and you can manage them with CLI. But basically, CLI is one of the kind of clients to your cluster, and this a web component is just another kind of cluster. But it can add more features that are impractical to implement in just this decentralized cluster model. I know, like things like watching a repo and automatically building code on pushes or stuff like that. It's not very clear how to implement in the current Uncloud model. But if we can have like a separate component, like a standalone component with like web interface, this is the place where this could be implemented. But that's still probably my main focus will likely be on day two operations and help with day two operations, like providing observability, monitoring, alerts, backups, recovery. This critical and time-consuming stuff that everyone wants to just work, but it's so tedious to set up. So, the current hypothesis is that this is what could be provided out of the box as a managed service.
That makes a lot of sense.
You will,
Yeah. I mean, here a lot of people, they all like the developers is waking up to the necessity for telemetry data, but then you start to play with it, and you either unload your bank into Datadog's bank account, or you fiddle with Grafana for a long time. So that sounds like a very, I think, feasible path forward for you guys. Like a complete telemetry setup would be nice on your own infrastructure.
Yeah, so we'll see. That's something that we need to test and validate. So this is probably the biggest part of the work that needs to be done. This is not the very, how I would say not pleasant, but exciting work to do. Like we all developers, we want to develop, not market, and not to do user research. But yeah, to build a business, you need to do this.
Yeah.
Yeah, totally. Returning to the fact of having some machines on the cloud and some in a home lab, for example. So is it something that you are doing? Was that something that I'm trying to wonder why would I do that exactly? Is it because let me give you a concrete example. So I'm building this app at the moment, and I know I will need the plausible self-hosting service. And instead of buying a machine on some cloud provider, I could host that locally and use Uncloud to now, because you were saying that there's some kind of DNS in there, so I could have some kind of DNS in my cloud server that calls my own machine, which would have the plausible self-hosting. So since it's a very, very low impact if it's down or not and whatnot. So I'm curious a little bit to hear about some use cases of what you have seen so far, or how you are using Uncloud yourself to bridge some cloud machine with maybe your own network and whatnot, and what are you doing with that?
Yeah, so I personally combine some machines in my home network with cloud machines to just run monitoring stack on the machines in my home network, because this Prometheus, Grafana, they use a lot of memory. Recently, I tested Victoria Metrics, which is just very cool project that provides a drop-in replacement for Prometheus and consumes 10 times less system resources, which is amazing. So probably the monitoring stack, if using Victoria Metrics, Victoria Logs, won't consume that much, but it's still usually several gigabytes of RAM and some CPU cores. And just for side projects, you can run it on your own machines at home if you have some home lab set up, and just not spend money on the cloud instances. But more critical workloads that require to be available, then you just run them on small VMs from cloud providers, from Hetzner, DigitalOcean, or whatever you prefer. So yeah, this is called the hybrid setup, when you just mix cloud with on-premise.
Yeah.
And typically this just for cost saving, but in some cases, and I hear this starts to be more popular in Europe, that data sovereignty is the subject that many people start talking about, and also exiting the AWS clouds and running on premise or some European cloud providers. So if data sovereignty requirements is something you have, then again you can combine your on-premise infrastructure and with cloud or your hosting provider infrastructure and run your apps in the hybrid model.
And as soon as I'm installing, or at least initializing the machine, you were saying that it install an agent on the server itself. So this server, if I were to SSH on there and ping another machine, it would work. So the DNS is also outside of Uncloud systems, if I can say that. Is the OS knows about the DNS internally in the network?
So you will be able to ping the machine if the VPN, the WireGuard VPN, is able to establish successfully. But the DNS part, I'm not sure. Can you clarify like what specific DNS? Because the Uncloud cluster also has its own internal DNS for the internal network, and it allows to resolve other services like basically resolve service names to the container IP addresses to talk to them. So this is similar to Kubernetes, if you're familiar. That also has an internal core DNS component. But I guess
it's really inside. It's really inside of the network. So if I'm SSHing, I cannot use that DNS. So let's say I have I don't know, for example, server A and server B would be my DNS name, for example. Server A could be my cloud machine, server B my own machine. Can I SSH into server A and do ping server B?
So, and server B is a public DNS record, or what is server B?
It would be using the internal Uncloud DNS. So I'm trying to determine if the DNS that is used internally is also able or available outside of. I don't know how to explain that.
Yeah,
if I SSH on the machine with the Uncloud agent, do I automatically have all the DNS resolved for me from my other machines? Okay, let me ask that. Another way. So I have a service. Let's say I have a web service, and for just for the sake of discussion, it's hosted on the cloud, and I want the database to be hosted on my own machine, for example.
Cool.
So I could have my web instance DNS be named web, and my database just DB. If I SSH into the web server, can I do anything with the DB Uncloud DNS name at all? Will it resolve to my own IP?
Mm-hmm. Yeah, so got it. So on the machine, when you just SSH, it won't automatically resolve, because we run the internal DNS on basically every agent. It runs an embedded, very tiny embedded DNS server, and it listens on the localhost 53 port. And we don't automatically update your etc resolve conf to point to this domain server, but you can manually update, and then from the machine you will be able to just pin DB, and it will pin the container with your DB on another machine. But when you're running another service in an Uncloud service, and within this service, you don't need to configure DNS. It automatically already points to this embedded DNS that resolves all your services running in the cluster, but just their name. So you can, in your application, you can directly specify the host name for your database, just DB. And it uses internal, db.internal, or internal you can just omit and use just DB, and it will resolve to your DB container.
Okay, nice. Do I have anything with that agent that would allow me to open a shell or something that would automatically use this DNS resolver?
You can open a shell in any of your running containers. So, and then in this shell you will be able to use the DNS. So you can. You can, for example, you can deploy your web application, and if you have, if it's built from some Alpine Ubuntu image that contains shell, then you see exec your application, your service name, and then it will open the shell inside the application container, and it will be able to use any DNS records there.
Okay, that's interesting. And And to be clear, there's no need for me to have Docker on the server first.
No, it's actually you can install it yourself, but when you run this machine init or machine add command, the part of the install script is installed in Docker on your machine. So it will be installed for you if it's not installed yet, but you can pre-install yourself your way, or you configure it your way you prefer.
Interesting. Morten, do you have any closing thoughts? Something to ask?
Yeah, I mean, I was kind of thinking if you had any like deployment mechanisms of updates to the agents, but I don't know if you already answered that, to be honest. So do you? Is there any like updating involved with the daemon running, or is that feature complete? I guess is my question. Are you happy and you don't need any updates?
So you mean like when I release a new version of agents, of daemons and CLI, how we roll out? So yeah, there's actually the open, even I think pull request that contributes part of it to create a new command to basically do the roll and update of agents on the machines. It's not implemented at the moment, and it's just in every release notes, I just include a snippet. You just copy paste and run on every machine to just download a new binary, already pre-built binary of a new version from the latest release on GitHub, and basically just replace the currently running one, and then restart the systemd service, and that's basically it.
Nice. Cool.
But definitely it would be great to automate it, to make it as a just, new version is available and you just run one CLI command and roll out the version. Yeah. But this is just like nice to have. It's probably not so critical.
Very cool project, Pasha. Do you anything you want to say to listeners? Are you looking for any contribution? Any feedback? I would guess is what you're looking for at the moment. You know, people using the tool and whatnot. So how people can help?
Yeah, so I would love feedback from users. So check it out, please. You can find my GitHub profile, P. Swiderski, basically P and my surname. And there are a couple of projects pinned there. One is Uncloud, another Unregistry. So check it out. Unregistry is the one you can also use without Uncloud. It just comes with a standalone Docker plugin, just a separate command called push, but push with double S for SSH. Nice. So basically you can run Docker push, and then your image name and your SSH target, and it will upload an image to your remote server via SSH. So it just does a little bit of manipulation with running unregistry container just in time and then clean it up. But basically it will upload the only missing layers to your remote machine, which will be available for running containers on that machine. So yeah, check it out, and please join our Discord. It's around 350 people at the moment there. Not a lot, but it's still something. And probably the feedback is the most what I want to hear from people, how they use it, because when it's not SaaS and just open source project, you have no idea like how people use it, and you only know when they come to you with their issues, and then you realize, oh, this guy does that. But probably many others just face some problems and gave up, and you don't know like where people dropped. So please let me know if you found something that doesn't work or you have any ideas. how to do things differently, or you have some bug, or you face some bugs. So please let me know.
Very cool project. Thank you for joining. If you want to return in a couple of months, 3-4 months, whatever, when you reach some other milestone, it will be nice to get some news from the project. It seems to be very interesting.
Yeah, that would be great. Yeah, thanks for having me.
Yeah, thanks for coming.